Hello and welcome to the second video on linear modelling, where we're looking at an actual A-level question regarding soap. In order to answer this question on soap, you need to understand the ideas of expenditure, income and profit. So if you're running a business, expenditure is all the money that you're paying out for things, income is all the money that you're taking in, and then profit will be the difference. So for example, if you spent £200 in expenditure, but your overall income was £300, then you would have made a £100 profit, which is 300 minus 200. So here's the question. A small factory makes bars of soap. On any day, the total cost of the factory, Y pounds, of making X bars of soap is modelled to be the sum of two separate elements, a fixed cost and a cost that is proportional to the number of bars of soap that are made that day. Part A then asks us to write down a general equation linking y with x for this model. So there's a fixed cost. They haven't given us a variable for that, so let's call that f. And then there's a cost proportional to the number of bars of soap. Let's call that c. And as it's proportional to the number of bars of soap made that day, that means it's c times x, where x is the number of bars of soap. So overall, our general equation will be y equals f plus cx, where y is the total cost of the factory, f is a fixed cost, and cx is the total cost proportional to the number of bars of soap multiplied by the number of bars of soap, i.e. this extra cost that is proportional. So we are told that the bars of soap are sold for £2 each. And again, like our previous examples, the world record and the giraffes, we're given two separate bits of information we can use simultaneously. So on a day when 800 bars of soap are made and sold, the factory makes a profit of £500. And on a day when 300 bars of soap are made and sold, the factory makes a loss of £80. And using this information, we need to show that y equals 0.84x plus 428. So the fixed cost will be the 428, and the cost per bar of soap will be 0.84. So we know that profit is income minus expenditure, or total cost if you want to call it that. And the total cost, if we rearrange it, is equal to income minus profit. So we can now use the information above to work out an equation for y, the total cost in both cases. So when we have 800 bars of soap, we're selling each bar for £2, so that's a total income of £1,600, from which we take away the profit of 500, meaning our total costs are 1,100. For the 300 bars of soap, again we have y equals, we times 300 by 2 for the income, £600. And because it's a loss of £80, that's equivalent to a negative profit of 80. So we're doing 600 take away negative 80, which is 680. So now we know the total costs, or the value of y, for both the 800 bars and the 300 bars. So using the formula we came up with in part A, which was that y equaled f plus cx, our total cost for the 800 bars is 1100. The fixed cost is f. The number of bars is 800, and we're timesing it by c. And similarly, for the 300 bars, we've got 680 as our total cost. F is our fixed sum, and we've got 300 bars of soap, so 300c. We now have a pair of simultaneous equations we can solve. They both contain f, so we can subtract straight away. We get 420 equals 500c, hence c equals 0.84, as we were asked to show in part B. We can also work out f, of course, because f is given by, say, 680 minus 300c. If we know that c is 0.84, we can work out f as 428. Part C asks us to interpret the significance of the value 0.84 in the equation and referring to our model. Well, 0.84 was the value of C, which was the amount of money it takes to make a bar of soap. So for every extra bar of soap, okay, it's going to cost an extra 84 pence to make. C is the gradient in this question, so it's going to change every time x goes up by 1, the total cost is going to go up by 84 pence. And then finally, assuming that each bar of soap is sold on the day it is made, find the least number of bars of soap that must be made on any given day for the factory to make a profit that day. So the least number of bars of soap implies that we're going to be solving an inequality. So I've started off by saying that y equals 2x minus the profit. So y again being the total cost, 2x being the income, because however many bars of soap there are, they each cost £2. So that's an income of 2x, and taking away the profit. And then if we rearrange that, we get that profit is equal to 2x minus y. And in order to make a profit, that means we are making a positive amount of money. That has to be greater than 0, unlike the loss we saw earlier. So I can substitute in for y in our equation, our 0.84x plus 428. So 2x minus, in brackets, 0.84x plus 428 must be greater than 0. Removing the brackets, we get 1.16x minus 428 is greater than 0. If we add 428 to both sides and divide by 1.16, we get that x is greater than 368.9655. So the least integer, because we have to have a whole number bar of soap, the smallest integer above 368.9655 is 369. So that is the answer to the question if we want to make a profit.